Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of graphing advanced polar graphs. The general form we're going to be addressing is the a plus or minus b sine theta or a plus or minus b cosine theta. And when we're doing these, we look at the fraction of a over b. That'll dictate what kind of curve we have. We do not care about the sign, hence the absolute values. So the way we're going to approach these is we're going to form any of these that have that basic formula or format. You're going to form a table that you're going to figure out what's going on at each main axis. So you're going to plug in a theta of 0, for instance, into your equation and then figure out what r is. And then plug in pi over 2, and then pi, and then 3 pi over 2. Okay? And you'll get 4 r values, and by knowing which one of the basic shapes you're dealing with, then you can connect the dots. Now for the top two, you will need to also set r equals 0 to find what are called the tangents at the pole. If you remember the concept video of polar graphing, the tangents at the pole give you your kind of like your polar asymptotes. So let's look at the first scenario. A over b is less than 1. We're going to go through an example of each of these, so just kind of try to absorb the concept here. Here we're going to have a limicon with the inner loop. This one's a little trickier because when we set it equal to 0, we get these tangents at the pole, and these tangents at the pole right here are going to dictate not only how far in our humps come, but they also will dictate how fat your inner loop is. Because if you extend those tangents at the pole and keep going, that'll guide your inner loop. So you will need to equal to 0 and do that table anytime it's a over b is less than 1, or if a over b equals 1, you'll also need to do the same thing. If it equals 1, it's this cardioid shape. You'll still have a tangent at the pole, and it'll still dictate how wide your humps are. Just no inner loop to deal with here. All right. One quick thing I forgot to note, right here, the negative radii lie between the tangents at the pole for the one with the inner loop. Okay. Again, no inner loop here. These bottom two, you don't need to set equal to 0 because it never touches the pole. It never goes back to the 0, 0 or any theta 0. All right? You do your table for 0, pi over 2, pi, 3 pi over 2, and you know because a over b is between 1 and 2, then you are able to draw this dimpled limicon. And then here we have convex limicon. Actually, that should be greater than or equal to 2 right there. Sorry about that. And again, because we never go back to the pole or the center, don't need to set it equal to 0, just do your table. All right? All right, so whenever you see r equals a plus or minus b cosine or sine, you should look at the absolute value of a over b and determine whether you have a limicon with the inner loop, cardioid, convex, or dimpled limicon. Once you've figured that out, then do your table with these 4 major players. Don't need to do 2 pi, it's the same thing as 0. Once you plug in theta and find what r is, plot the points. For the top two, if a over b is less than 1 or equal to 1, you're going to have to set it equal to 0 to find the tangents at the pole. All right? So once you do all that, you should be able to connect the dots and draw your shape. The extra step for the inner loop is extending your tangents at the pole to tell you how fat your inner loop is. And this point right here will come whenever you plug in this case, pi over 2. Will give you that negative 2 radius, all right, which is one of the main axes. So practice, practice, practice. I will do an example of each of these. Make sure you check them out. Thank you and have a nice day.